We're ready. All right. Welcome, everybody. Turbonomic Labs is live again this fine Thursday. If you're joining us, hopefully you're on the live session right now. I'm extremely excited. Thursdays are fun. My name is Eric Wright. I'm going to be your host today. We are streaming some really, really cool stuff today. I wanted to share in my use of open technologies that I've been sharing with the blog audience through what we're doing here at Turbonomic. So if you actually go to turbonomic.com/blog, you will often see stuff there. Number one, subscribe to the blog, please. Also, subscribe to the channel. Hit the little bell icon below there. If you're watching us on YouTube, please do subscribe. You'll get notified when new things are coming out. Comments, thumbs up, anything is always beneficial as well. Just let us know whether we're doing something good. And of course, this is interactive. So if you pop in any comments, if you're watching us on LinkedIn Live, if you're watching us on any of the other platforms, then please do. Sorry, just get positioned here. There we go. If you just drop in a comment, it'll actually come through right during the live session. Today, as I said, on the Turbonomic blog, I've got a regular series going called Couch to Cloud Native. And the impetus behind this is the idea, if you've ever seen like running groups and people that are getting used to, getting started with running or effectively getting started with anything, we called it the Couch to 5K program. It's one of the most sort of popular early, getting started with running programs. And the idea with Couch to 5K is you don't need any experience. We'll take you from just literally sitting on your couch. I'll get you through 5K so that you can get a sub 45-minute 5K and you're going to feel great. It's a training program and it's short, right? It's meant to be consumable so anybody can do it without a huge commitment. So with that, this is where the driver for a lot of the content that I'm creating, especially this idea of Couch to Cloud Native. Couch to Cloud Native is moving from a traditional, I'll say, monolithic virtual machine type of concept to deploying cloud native architectures, not cloud native like running on Kubernetes, but the Couch to Cloud Native part of this is that we're going to teach you how to run a cloud native architecture in staged processes using infrastructure as code. Super easy. I'm literally giving you the whole code on Vsphere. So the background to what we're doing and what's in the blog series, and if you actually go as well, remember, if you go to follow any of the stuff we're doing here at Turbonomic Labs, you just go to github.com/Turbonomic Labs. We've got a sample there. You can see on my screen right now. It's called Couch to Cloud Native, or C2CN. And this is the monolith to multi-VM blog series. So what we're going to do is actually walk through the first part of this because I want to get you started and show you literally how easy it is to kick this up. Because what we find often is that people, they'll read a blog, they'll check out a documentation, they'll read a white paper, they'll do something, but they don't actually get to see it happen. And so I'm going to walk you through exactly what this first part is. If you go and you click on the link, it's actually a live link right in there. It'll take you to the blog. Look at that. I know that guy. I think he's a decent author. So if you go to the Turbonomic blog, I'll zoom in there. Sorry, I can't zoom in. Look at that. How's that for a stream fail? Can't zoom my second monitor apparently. But what you'll see here is exactly the idea in designing what we're doing. The reason why we're looking at Couch to Cloud Native as an architecture, not as a technology, is because it's a way in which we're going to deploy technologies. And I actually walk through in the blog very specifically, what the logical and physical architecture is. And in fact, I even go through the core of why you would make an architectural decision using whether you call it ramps or ampers. So availability, manageability, like it's effectively TOGAF or VCDX for the VMware kids. So availability, manageability, resiliency, performance, and security, going through these kind of core. So we're going to simplify it purely just on nailing down what a conceptual design is, what our logical design looks like, and then ultimately what our physical design is. We fast forward right to physical because we want to say that logical architecture, today I've got a simple app running with a database and it interacts with other things. So today I'm actually deploying it. This is a single virtual machine. We can have, front end. In this case, I chose Nginx Ruby on Rails because I'm a big fan of Ruby on Rails. Shout out to the kids over at Basecamp and at DHH. If you aren't following them on Twitter, you should. MySQL and MongoDB. Now today, you could easily deploy any of these. And in fact, I'm going to, as part of the last blog in the series, which is about to drop, we actually document the code to implement all of these technologies. So you could literally download a core image and use code to deploy these apps inside that machine. But the cloud native is the idea that you can take this architecture and you can break it out into a pattern that will work on cloud native architectures. Fundamentals of cloud native architecture. Assume that it goes away. You call it pets versus cattle or whatever you want. We want to be able to ideally have immutable infrastructure. So we just push an image out there, a core machine, use code to deploy the latest application code, and that's it. We want as much stateless architecture as we can because you don't want to maintain state in the machine. So what you're seeing is this idea that we're going to take what was now one virtual machine and spread it out across 3 VMs. So we're going to put a load balancer in front of it, whether it's hardware, software, whatever it's going to be. In this case, we'll deploy an Nginx load balancer as part of the series. Not today. We're going to start slow. 3 virtual machines so that we can take this stateless front end and then now put in the back end as services. So the reason why cloud native on virtual machines is powerful is because it prepares you for how you're going to build and deploy on cloud or just on private cloud. There's no reason why you can't have cloud native architectures on premises in virtualization, whether it's on Hyper-V or Vsphere, whatever your or Red Hat Enterprise Virtualization, whatever your hypervisor of choice is. And again, the impetus behind this is that you today are administering single VMs, and we want to take you to this next stage. So today we're going to go through the first blog and the process, and you're going to see me, show through the code what it is and show you stuff to watch out for as you do that first deployment. So the next piece is, like I said, we actually go through, and I chose to use everything as systematized approaches because wherever possible, I don't want to be using right-click new VM. And that's effectively how we've done a lot of it. Even if you're using templating, which is fantastic, you're getting warmer. But using a template doesn't get you to the point where it's easy to repeat, because what if I need to spin it up and tear it down quickly? What if I needed my development team to be able to spin it up and tear it down quickly? Right? So now we can use infrastructure as code. So going back to the actual GitHub, if you're looking at the GitHub, there we go. Sorry, make sure I'm pointing in the right direction. It's like looking in a mirror. If you look at the code that's right there, it shows you that I've got part 1, rather unexciting because it's actually just the architectural discussion. Part 2, which is actually where we're going to get into today. All of the code is right here. So you can actually fork this, you can clone it, however you want to pull it down. You can get a copy of this content and you're actually seeing what I do, and you can take that. So there's a couple things that aren't in there, which is what we're going to walk through today. You also need to have Terraform, and you need version 12. So let me just go through that. Terraform, I think it's terraform.io. Yeah, terraform.io. There we go. If you go to terraform.io, shout out to my good friends over at HashiCorp, who have been fantastic for a number of reasons. So you can grab the CLI. We're going to use the open source non-shared one. So this is literally just you deploying code locally. We'll move further as we get into the series into how you bring it over into cloud and use shared state and shared repositories. but just go get the CLI. You want version 12 because there's pretty big differences between version 11 and version 12. So go grab version 12. You don't have to, if you can't catch up right now, don't worry. You can pause. You can watch this again as it actually goes on a replay. So you go get your Terraform. The next thing you're going to need is Vsphere. So I'm actually using my lab here, and it can be whatever version that you want. If you're familiar with VMware Vsphere, you'll notice some newness to what I'm doing here. So this is actually Vsphere 7. Very, very cool. Lots of neat capabilities in there. And what I've got as a very simple beginning is I'm using a template. I'll go to my VMs and templates view. And the template that I'm using is actually going to be using Photon Os because it's fast today. And then as we go through the series, actually we'll build it on CentOS as well, which also open source, free, and widely adopted. So very good. Photon is just faster right now because it's a much more sort of simplified operating system. So you can download Photon OS. It's again open source. You can get it off the VMware GitHub. Just do a search for Photon OS. So it's super small and lightweight. This particular machine, they're 1 gig, 1 CPU, 16 gigs of disk, very, very minimal. So I've created this template. It is literally, at this point, is nothing because I want to start you from the beginning. So we're going to try, how do you use Terraform and VMware to just do the first deployment of a single machine from a template? And then from there, it escalates quickly. So now that you've got Terraform, now that you've got your VMware environment, we're going to bust open that code. So if you downloaded that repository, there's some core files that are in there. What I'm going to do, and try not to click on it by accident so I don't show my secrets, there's a way in which you can use a sort of 12-factor approach. And this is important because you don't want to code your secrets, aka passwords and usernames, inside your code. You notice I've freely shared this, and in fact, there may even be some references to cluster names or something that's inside the code. Kind of a bad idea. Okay, it's a really bad idea, actually, not even kind of a bad idea. So what I've got is I've created a little exports file. If you're running Mac OS or Linux, you can also just have a batch file for setting environment variables on Windows. And inside here, I'm actually just exporting a bunch of variables into my local machine. And the way that you do this, again, I got to be very careful because I could accidentally click on it and show some stuff that we don't want public. That's why you should ideally use a password vault. We'll get there too. But you just name every variable that you see. So when you see in this code and it says var.vsphere_user, anywhere where you see that reference, all you need is in your environment to have a variable named tf_var_ whatever this name is. So it would be tf_var_ vSphere user is what you would see in my local environment variables. And the reason why that's handy is I've got like 7 different Terraform environments that I'm managing locally right now. So all I got to do is go into the folder. I keep my exports file. And then because I'm doing that, I can just run the exports file, run Terraform, and I'm always in that localized live environment in that shell command. So it's important to use this as a method. Like I call it 12-factor. It's about, it's about 3-factor at this point. Just the fact that you're not storing your username explicitly in the file. So the files that you're going to see when you download, number 1 is the provider file. We're going to take them not in the alphabetical order, but the order of what matters to them. So your provider file is the way that you connect to whatever your backend service is. In this case, my provider is Vsphere. So I've actually identified provider of the Vsphere. It has 3 specific things that it needs. 1, it needs to have a user, it has to have a password, and I need a vCenter server. It can also be a local, just standalone ESX host. However, a lot of features aren't available when you're only running an ESX host. So you're going to want vCenter. And this is the nifty one as well. So you just have to say allow unverified SSL equals true. And shout out to anybody who can name it why we do this, because we don't have public accessible certificates. Like I'm not using a verifying cert, or I'm not like publicly accessing this through a public URL and a public IP address. So I can't even use Let's Encrypt. So I can't use, certificates. And unless I've got an internally self-signed or like a non-self-signed, like an actual CA signed certificate, I have to set this up. So if you're using a self-signed certificate, just set allowed unverified SSL equals true, and you're good to go, which is good. So now what you've got is your basic vSphere provider. That means this is what I need to connect to vSphere. When you're in your folder, you download the code. You go, in this case, to the part 2 folder. So I've got C2CN Terraform samples, monolith to multi-VM, which is the blog series, and I'm in part 2. Take a look. Like that, I've got a couple of different shell files. They're also, for your safety, I've specifically named them exports.sh, and it's ignored in the git ignore file. So they will never commit back if you were to accidentally put stuff in there. So I've got my provider, and what you run is a Terraform init, because you want to make sure that it gets the latest version of the provider. In this case, I'm already good because I've built this, but you on the first launch will get, it'll pull, make sure you're using the right version. In this case, it's saying vSphere version 118. So it's already got that downloaded. Life is good. So I'm clear there. So that's my provider file. The next one is going to be my variables. So again, I've got to define these variables. So first, you set your provider. Next, you define these variables so that we can know that we're going to assign values to them. So we define the variable. I need a data store. I need a cluster. I need a resource pool, a data center, folder. You can also set templates. There's a couple of different options. So right now, you can put in documentation in here. I've not been as good as I should be. So I've just said literally create a variable. So we've instantiated a variable, I guess is probably the right word for it. And now what we're going to do is then go in and we've got our data file. So the data file, or data file, depends on what part of the world you're from. The data file, for the Canadians in the room, we're going to go through and say all of these explicit instantiated variables, I'm going to assign data to them because this is going to get used later in the file. So I'm going to say vSphere data center is the object type. We're going to name it DC because it seems like a good thing to do. You could actually call this Pete. Doesn't matter as long as you always refer to Pete later on. So I'm going to call it DC. I've got data store. And what you're going to see in this example, and you'll see often in your Terraform for whether it's VMware or whether it's AWS, is number one, you assign based on the name of something. However, what you really need is an object or like a unique ID. So quite often we will go and say, this is relative to something else. So the data center and the data store, like you'll see a repeated reference here to data center ID. And that's because I need to know the data center ID to match this resource pool, to match this cluster. So each object definition that I'm creating here has to then be mapped. So we've got data store, resource pool, cluster, my network. So here's an example. I do want to show both sides of it. You can explicitly assign it, right? So I've called it VM network. You could call it Joanne. You could call it whatever you want, whatever it is in your vCenter. In my case, it's called VM network. If it's NSX, whatever it's going to be, you would assign the distributed switch name or the network name. So could be assigning this as a variable, and I've chosen not to because I want to show you kind of both sides of how you can configure. And the same thing for my template. So I'm actually just explicitly listing the name of the template. If I go over to my template here, it's called TMPL_Photon, which is, it just happens to be my naming convention. Again, you could call it whatever you want. I'm not using a folder, so I've actually commented this out. If you have anything with a hash symbol, hashtag for those kids who know it, or a pound symbol, then that means that it's comments, so you don't have to worry about it getting dealt with. So we've got provider, check. Data, check. You would call these, again, the file actually could be called anything you want. This is the magic of Terraform. It will take all of this content, pile it together in memory, and organize it for you in memory. So you could call this Pete Thomas water.tf. As long as it's called .tf, it gets dealt with and it gets processed. So now I've got my data, and then I'm going to go to my main. We just use common naming conventions because it's generally accepted that these are the names that you would use. So the main.tf is where I'm actually explicitly creating my virtual machine object now. So it is a resource. So that virtual machine resource, the resource type is vsphere_virtual_machine. That's a definition from within Terraform. We're going to call it VM. Like I said, you could call it Dragon. You could call it whatever you want. I'm giving it a name. I'm calling it web-dev. The resource pool ID. Now, again, so based on that other file, I'm assigning, I've got a variable, which is in memory. I'm taking a data object and I'm assigning the memory, in-memory variable value to the data. And now what I'm doing is in the resource, I'm referencing the data object, and it will use the ID. So you're going to see that sort of nomenclature. So vsphere.resource_pool.pool.id. So that's simple example, but that's how you do it. Then we've got the data store. If we have folders, there's a couple of different ways that you can do it. I've got it here, but they're commented out. I'm going to give it a couple of CPUs. I'm going to give it 4 gigs of RAM. The firmware, this is a neat one that a lot of folks are starting to bump into more and more now. If you're using UEFI versus traditional BIOS, you have to make sure that you assign this, because Terraform will assume that it's using BIOS rather. So if you've got an EFI definition, which Photon Os happens to be, it will try and use BIOS as the format, and your machine won't start. You'll get a guest network not found, or a guest OS not found. Because I'm using a couple of different template types, I can say I've got CentOS assigned here. It's commented out. So the guest ID, if you go under your virtual machine type, then you can actually see what the guest ID is. You'll probably recognize that from a few other things, whether it's Linux or Windows or whatever. So there's a shortened form. The magic part about this, you don't actually need to know this. If you type this wrong, you type the wrong one, Terraform will come back and it'll kind of flip out and it'll say, hey, you're using the wrong object type for this template. It should be this. So it's kind of handy. This is also a nifty one. Wait for guest net timeout. This is specifically built so that I don't need to wait to get an IP address. If I'm using a local lab or it takes a little longer, this will have, I believe it's a 5-minute timeout. So after 5 minutes, it'll stop waiting and it'll error out, but it will wait for 5 minutes. Let's assume I've got a fairly complex build, or it takes a while to get an IP address, or maybe I don't have one because I'm just testing. If you set guest net timeout to 0, as soon as it detects the power being turned on to the machine, it bails out and it just lets it go. So not always good, depending on whether you're using it to feed other parts of the process. But for now, we can set the net timeout to 0. My network interface, I'm assigning a single network interface. Disk size. So this is, even if you've used a template, you have to still explicitly assign a disk size and type. So I'm going to use thin provisioning. It's 16 gigs. We call it disk 0. That's the default. Disk 0, disk 1, disk 2. You can sense where it's going. And then the clone, because I'm using a template from, or clone from template, the clone is referring to the template UUID, which I don't know and I don't want to know because it's dynamically generated. I'm going to go based on the data object called Vsphere virtual machine dot template. So we go down here to the template where the name is template photon, right? So now it's going to take that, get the ID, and assign the template UUID, which is what we need in order to generate. Whew, I know, if you're tired like me, I'm sorry, that's a lot of information, but this was the walkthrough of exactly what you need. So you've got your provider. You then have your variable set. You've got your data objects assigned from the variables. And now you're actually in your resource. So it's a single resource, nothing fancy. It's explicitly named, explicitly assigned. And then the last piece is outputs. So once you're done, when you run this, it will generate, there's certain programmatic outputs. You can be, virtual machine name, if you're doing like a customization and it pulls it from the VM name or something like that. There's lots of, either statically assigned or programmatically generated dynamic, objects that are able to be queried and put in here. So in this case, I'm actually grabbing guest IP addresses. Bit of a bad example because I don't have my DHCP run in IPv4 right now, and my DHCP for IPv6 is also not working. So what you're going to see in this example is it's just going to come back empty. So that's by design. Blame the guy that's doing the stream. Okay, so I've assigned my export. So I'd say I've already set. Oh, sorry, I'll zoom this in a bit. It's a little hard to see there. There we go. Hopefully that's better. I apologize. There's nothing worse than when you see somebody typing on a tiny little green screen. Okay. So we'll start at the top. The process that we go through is a simple process. Number one, Terraform. We already did init, so we've initialized the folder. We've run our variables, so I've got it in memory. Again, I can't show you because it's actually got passwords stored in there. I'm going to say Terraform validate. So validate, what we'll do, it will check to make sure that you've got the right syntax, that it's not referring to an object that's dead or other things. Here's a neat thing from version 11 to version 12. You're going to get this thing called interpolation only expressions. So where I've taken an object and I've assigned it to a referential object. So it's called interpolation, where you basically a variable that's created from a variable. Something like that. If you're a programmer, you know what interpolation means. I don't know. But what it means is that I'm generating this based on this. So in version 12 of Terraform, you can now just type in vsphere _ user here. I don't need the $, curly bracket, var dot whatever. I'm old school, so I still left this in there. There are still oddities around this. So if you get interpolation only, it just tells you. And 2 more similar warnings elsewhere, which means there's more than one spot where I've used this interpolation. It is only a warning. It will run fine. If there's an error, you'll get a big old red thing that says there's an error. So we've done Terraform validate. We know that we're good to go. Now the next thing we're going to do is we're going to do a plan. So Terraform plan, it's going to go and it's going to check to say, what's going on in my environment when I do this thing? So what it's going to say is that at the bottom, it looks like I did the same thing as before because you see the same bottom. That's just the warnings. So you can see here it says plan 1 to add, 0 to change, 0 to destroy. And this is the very detailed version of what we're about to do. So it's going to create a vSphere virtual machine. This is a combination of the stuff that we've explicitly assigned. So you can see things like firmware, you can see the guest ID. Like this is stuff that's in our file, and some that's automatic, that's default, some that's programmatically generated where it says like known after apply. So it's not going to get, But here's an example. Remember I said outputs, you can get hardware, host system ID. There's lots of really cool stuff that you can generate. So if I wanted to get my outputs, I could actually go in and put host system ID, and I could gather that information at the end. So all this different. We've got the name of it. I specifically assigned it. I'm going to call it web dev, migrate. So there's a few different thresholds around wait times that you're going to see in here. And again, a lot of this idea of known after apply, which means these are dynamically generated, which is cool because if I generate it now and I generate it in 20 minutes, they could be different. There'll be different UUIDs. So now that I've done this, we've done a validate, confirm that our code's good, plan, see what's going to happen. And in fact, one that I should have probably started with is if I can do a show. So show says, what's the current state? And it compares it. It's actually going to the live state to confirm. So there's absolutely nothing. I feel like a magician. As you can see, there's nothing up my sleeves. I've done a Terraform show. There's literally nothing there. So the last thing we're going to do is say Terraform apply. Now, if you hadn't done a couple of things, you'll get a different warning here. So this is saying that familiar pile of interpolation stuff telling you that, Eric, you're not a particularly good code writer. You could have gotten rid of interpolation. Pardon me, because I've done this before, and then it throws an error about interpolation. So in this case, it's just saying, all right, you're good. We've done a pass. So it's actually doing a plan. It's doing a validate for you. In this case, it's saying, do you want to perform these actions? I'm going to say yes. So now it's going to begin. And you'll see, let's go over to Vsphere. Ah, look at that. So if I actually go into my vCenter UI, you're seeing the clone of a virtual machine take place. If I go back over here, and I can actually watch this is occurring live as we do this. So this is kind of cool. As I mentioned, just while we're waiting for this, because it takes about a minute, if you had not put in your information in the variable, so if a variable is missing an assignment, it will prompt you at the command line for those variables. It'll say like, what's your data center? What's your resource pool? What's your cluster? And there we go. So that's why I use Photon, because it's wicked fast. So it took 40 seconds to complete. I go back over here and I see my friend here. Now look at that, web dev. Now, remember I said there was a guest net timeout set to 0, so it's not going to wait for my guest network. So if I actually launch this and wait for it, you're going to see a rather unexciting dead console because there's nothing there yet. It's actually doing the first launch. Takes it a moment to spin up. You can see under IP addresses, there's nothing there. So if I had set guest net timeout, it would have waited before. So you'd see here, it would still say 40 seconds, 50 seconds, a minute 10. Like every 10 seconds, it will remind you that there's still stuff going on. And after 5 minutes, it'll tap out saying there's a problem because it didn't come back fast enough. You can actually set the threshold to be longer than 5 minutes. But so it's going away, and there we go. So we can see right now I've got an IPv6 address. It still hasn't actually lit up the virtual machine because this is the first launch, so it takes a few more seconds. But that shows you, doesn't seem very impressive necessarily, because you could have just said right-click, new version, name it, and you go through the wizard. So in fact, just for funsies, let's do that. So I'm going to say new VM from this template. So normally you would go in, you would say, call it web dev 2. You choose your cluster. Or sorry, you choose your data center. Now you choose your cluster. You could actually specifically assign it to a host if you wanted to. You select the storage location. You select your policy for storage. You select whether you want to fire it up when you're done. I say power on. So it would go ahead. You can do customization. So it doesn't seem like that particularly onerous, but the difference is that I had to do it. I had to right click, do a thing. Well, what if there was 40 virtual machines in my application set? So that's what you're really doing, right? It's not just for me really quickly doing one machine. It's the idea that now if I do a Terraform show, remember we had a lot of that stuff that was known after apply. Well, now that's all known. So you're seeing things like storage policy ID, you're seeing other content which is there, which is very handy. So the good thing about this means that you can use these programmatically by other processes as well. So you can actually have one machine that feeds off another. So grab the name of the one machine, use it to generate the second one. And now I get my data store ID because that's dynamic. I wouldn't have known that until it deploys. So you can use your placement you can even have it pull for third-party platforms, wink, wink, like Turbonomic. So it tells me my guest tools, whether it's running or not. In this case, it's not running yet. And all this, so you can basically imagine that all this is available programmatically. And in this case, I've got my output. So normally you would type in Terraform outputs, output. And Terraform output will regenerate all of the outputs that are defined inside your object. Let's go back over to Vsphere, see what's going on. I already had the console up. There we go. So my machine is now up and running. I could log in. So it is a live machine. And in effect, the programmatic time to do that was very short. So how does this relate to what we just did? Let's recap. The purpose of this is I want to be able to take this one machine and generate it programmatically. Because if I wanted to do it quickly and I go, oh, I want to try something real quick, I'm going to say Terraform destroy. So I'm going to get rid of my VM. Instead of right click, remove from inventory, delete VM, I'm just going to say, go ahead, delete it. I go back. Let's take a look at Vsphere. Oops. There you go. Delete virtual machine. So you see everything show up because it's really happening at the hypervisor. It shows me as one destroyed VM, Terraform show. I wanted to change my template or make some minor change. So I make a minor change, go into my code, set it as a different size. Let's just, what if I wanted to do something like maybe I'm going to set it a little bigger. Oops, where's my main? So I go to my main file. I'm going to give it 4 CPUs. And I'm going to give it 8 gigs of RAM. You can make this any number you want. It doesn't need to be a binary number like this. I'm an old ops person, and so I like everything to be on the bits. So Terraform validate, make sure everything's cool because I made some code changes. Terraform plan, just again, make sure that the machine isn't already running. Terraform apply. And now I'm going to show you one last thing before, as this comes up, in what's especially valuable. So this is stand it up, tear it down. Really repetitive stuff you want to do. You want to be able to do this quickly. You want to be able to do it for your labs. You want to be able to have your developers deploy their own resources. Fantastic stuff. So what I've done is, in fact, I've kind of like cheated on my use case because I showed you how to spin it up, how to tear it down. I'm making a minor change to it. Well, what if I wanted to spin it up and make that minor change? I mean, you could say, oh, Eric, you could just go into vSphere, you can go into vCenter, you could do that. Well, I actually don't want to make that change in vCenter. I always want to do it programmatically. So now what I do, so it's coming back up. It's going to take a few seconds. Oops. Terraform show. So it's now, again, relaunched. If I go back in, I go to vCenter. There's my web dev machine. It's slowly coming up. Again, first launch because it's coming from a template. So there's a few things that are happening. So we're going to wait a second. And then we're going to show you the next little trick. One last thing before we go. It's like that Columbo. One more thing. I'm also old enough to know Columbo. That's how you can tell why I'm an old IT ops kid. So my use case is spin it up, tear it down fast. Beautiful. There you go. There's my IP address. So I'm good. I've got a live machine. It's going to take a second more. It's just coming to the screen, but it's actually launching. Now, if I make a change here, it's not going to match my code. Why is that important? Because I want my developers to always use this way to deploy. I want my other IT ops team to always use this as a way to deploy. So if I change it in vCenter and it doesn't match, it's going to get angry because it's not going to line up. So now, the reason why I'm going to show you why that's important, I'm going to say Terraform Plan. Once I'm already running. So I'm going to say check a plan based on what I believe the state should be, based on my definition, relative to what's actually going on in the live environment. So what's going to happen is it can look through and say, hey, there's actual changes that need to be made. And this is because it's actually detecting disk changes. And then what I can do is I can, even more importantly, let's go right into the code and say, you know what? I don't want 8 gigs of RAM. I want to go back to 4 gigs of RAM. So now I go back in Terraform Plan. Now this time, it's going to tell me, again, interpolation warnings, lots of interpolation warnings. It's saying there's one resource to change. Now, this is not one change, but one resource that's changing. And that's because I defined this resource. So you'll notice that the storage policy here, this is the little red mark tells you that there's a change that's pending. So this is because it was dynamically discovered, and in fact, it doesn't line up. So I've told it to go thin. It probably went thick. It got angry, and so it's going to make a change. It also shows a few other things about annotations, which are kind of cool. But what I'm doing now is I want to go in and I want to make the change right here, which is I'm going to move my memory from 8 gigs down to 4. In code, and by doing it in code, that means that I always know that I'm getting the right version. So let's go down. Oops. Terraform Apply. So what happens when I say Terraform Apply, that I'm doing a hardware virtual machine change? It's going to go and begin to make the change. So if I refresh my vCenter, if it's a hot add, it will make the change on the fly. In this case, it wasn't. So it's actually going to apply it in some cases and reboot. Pretty cool. So look, and that's actually that fast because that's the beauty of Photon. So it's going to say, shut down the gas, do a thing. There's lots of different options, right? Oops. So let's say yes. Also, keep your eyes on that. I've done that before where I sat there looking at vCenter for 20 minutes, wondering why it was taking so long. And that was because it wasn't taking long. I hadn't hit yes. Okay, here we go. So reconfigure, power on. Take a look at the VM hardware, 4 gigs. Again, the value of this that's related to cloud native is that this is for one machine. And this one machine now, I'm using VMware. So I'm using my old toolkit. I'm using Terraform, so I'm using a better way to manage my old toolkit. And then on top of that, what happens when I take this and based on that kind of idea, if I wanted to now deploy 3 VMs for the front end and 3 for the database and 3 for a NoSQL environment, what if I could create all those in code and deploy my entire environment? And it would take me seconds to run and basically 9 minutes or so to wait for it to power up. over and over again, right? So this is where the advantage comes. If you're doing stuff, anything that's repetitive, this is how you should think. Thinking as an IT architect, and what can I do very quickly to do this? If you want it to be long-running infrastructure, it's a little different, because remember that state changes. So we'll talk about that another time. But this was couch to cloud native. So I've got on-prem vSphere 7. It works with 6, works with 5 even, and then using Terraform to spin up my machine. So in a matter of maybe 60 lines of code, if I want to make a change, I can make it anytime. So I go in, make the change, run it. Very easy. So again, go to github.com/Turbonomic labs, all one word. You can get access to the whole repo. You can go to the turbonomic.com/blog. If you check out the repo, it has the links to all the blogs. Subscribe to the blog, and you're going to see when the next 2 come out, because we are now going to go from that one where I took it, and in the second show, which we'll do. Oh, sorry. Our production team's like, why does Eric keep going back to things? There we go. Part 3 is I'm taking that same concept, except now what I'm doing is I'm explicitly assigning 3 virtual machines for my front end, and 3 virtual machines for my back end, and 3 virtual machines for my NoSQL. So I've now programmatically done this. And then in number 4, which is coming out next, I'm going to use a simple loop to generate these dynamically. So I'm going to do 1 code stanza with a loop, and it will do it 3 times. So you're really going to see the difference between, as you get better at this, how to actually simplify your code. So that's the last of what we'll talk about today. I don't want to go too much further because we've covered a lot, but I hope this is helpful. So follow the blog, subscribe. You'll get notified when the next one comes out, and it's very, very good for you to kind of keep an eye on, because we're doing a ton more really cool open blogs. It's not just Turbonomic content that's there as well. Of course, if you want to keep up with Turbonomic, you can do that. And don't forget, Turbo Tuesdays are coming up. So Turbonomic Labs is proud to broadcast twice a week right now, every Tuesday and every Thursday. So if you go to turbonomic.com/labs/live, then you'll be able to see all of our upcoming schedule. We got some really, really cool stuff that's going on in the cloud. We're going to do a follow-up episode to this where you're going to be able to see how we go to the 9 virtual machine deployment, and then how we actually do the application deployments within them, again, leveraging infrastructure as code. So I hope that you've enjoyed this. I hope this is helpful. My name is Eric Wright. I'm at Disco Posse. Disco Posse, there you go. There, God, it's really hard to do that on the camera. There you go. You can see that, and smash that like button. Do all those things. Make sure you do come back, and thank you very much for sharing your time with me today. I hope to see you again. So join us on Tuesday. If not, join us next Thursday, and we're going to talk about open technologies, and we'll see you then. Thank you very much.